Hello students, Miss Slyman here. I'm talking to you about lesson 43. This is our trig ratios in all quadrants. So first of all, quadrants implies that I'm looking at angles in an XY plane. So this differs from geometry. In geometry, we can just put a vertex anywhere that we want, and then we're going to measure the angle, always measuring angles that are between 0 and 180 degrees. We know, of course, in trigonometry that we could also measure our reflex angle, which is the angle that's greater than 180 degrees. So that's called a reflex angle. But again, that's only in trigonometry. It's not a geometry thing, or at least that's what Mr. Physico tells me. All right, but we're talking about angles in quadrants, which means we need to orient our angle based in the XY plane. So we're going to put our vertex always at the origin. We're going to think of the x-axis as our initial side. So that's our starting side. That's what initial means. Our terminal side could be the x-axis again if I had an angle of 0 degrees or 2 pi radians or 4 pi radians. But if it's anywhere else, then I'm going to, well, regardless of where it is, the second arm in the angle is going to be my terminal side. So we say that this position is standard position, vertex at the origin. That's how we always want to draw them. And initial side on the x-axis. All right. So now we're going to look at positive, negative angle measures. So you've already seen that we often use theta as the angle variable, but really any Greek letter could be used. So here we've got beta, and beta is showing how we measure positive angles. So positive angles we're always going to start at the x-axis, and we go towards the y-axis. So over here, we've shown the negative angle where we start at the x-axis and go towards the negative y-axis. So here we're going towards the positive y-axis, and down here we're going towards negative angles to the negative y-axis. Notice this angle alpha, I've denoted which way that I've gone by putting this arrow. If we had gone this way, it's the same angle. We've ended up at the same terminal side, but this direction would be the positive angle. So if I wanted to use another Greek letter, I could say phi, for example. And in this case, phi is a positive angle. And we know that that angle is also greater than pi radians. Down here, alpha, we could say that alpha is between, so my negative side is going to be negative pi less than alpha less than negative pi over 2. So here would be my negative pi over 2 because we know, of course, that 90 degrees is pi over 2 radians. Over here, we could say that phi is between pi and 3 pi over 2. So we've said that these end at the same place. Well, we call that a coterminal angle. So in this case, phi and alpha are coterminal. All right, so you've been asked to sketch an angle of 125 degrees and then state a positive and negative coterminal angle. So let's start by doing that. So I know that 125 is greater than 90 and less than 180. So in fact, it's 35 greater than 90. So I'll go about there. Really, I would have liked to have made that one blue. Okay. So now I'm going to put in my measure. So going this positive direction was 125 degrees. Well, another coterminal measure, I could have started with the negative. That's going to be the easiest. So if I go this way, I know that the remainder here is 55 degrees because 55 and 35 would make 90. So that's going to be negative 180 minus another 55. So that's going to be negative 235 degrees. So I could say theta 1 is negative 235 degrees. If I wanted another positive angle, well, I can't do 125 because that's already been used. So I'm going to wrap around. So I'm going to start again at the x-axis. I'm going to go all the way around once and then hit this again. So that might be hard to see. I'll make it maybe a darker green. So theta 2 is going to be 360 for the full circle I went around, plus 125. So that's going to give me 485 degrees. So both of these are coterminal with my original angle of theta was 125 degrees. So notice this one's 360 plus 125. This one is 125 minus 360. I could have just kept going around and around and around and around. Every time I go around, I'm doing multiples of 360. So to think about this red one in terms of 360, well, I could have gone all the way negative 360, but then positive 125 to take me back there. So an expression that gives all my angles coterminal with 125. So I could say theta sub n is 125 degrees plus a multiple of 360. K has to be an integer. And it could be positive or negative because I can measure positive direction or negative direction. And I said theta sub n, sorry, because I used all those k's, I should have said theta sub k. So my original one, k was 0. I have 125 plus 0. I get that. This theta 1 in this term would actually be theta negative 1, and I would have done 125 minus 360. It doesn't matter if I'm talking radians or degrees. So here we have an angle of 7 pi over 6. Well, the way that I always think of this, that's a full pi plus pi over 6. So if I'm going to sketch that, I'm going to do a full pi. So that's going to take me to the negative side of the x-axis. My shape's default. All right, so I'll go there, and then I'll go a pi over 6, which I know is my short angle. So I'll put in my angle there. I'm going to call that theta. 1 positive, 1 negative coterminal. Well, this time I'll map out the negative one. So I know that going all this way around would be negative 2 pi, but I need to end up here, so I'm going to bounce back to here. So I could say theta negative, so I'll call that theta n, would be negative 2 pi plus 7 pi over 6. Well, in sixths, this is negative 12, so I'm going to get negative 5 pi over 6. I could also have thought of that as negative pi plus pi over 6. My positive coterminal angle, I'm going to do a full loop, so theta positive. I'll go a full 2 pi, and then I'll add another 7 pi over 6. Again, that's 12, so I get 19 pi over 6. So my expression for all angles is going to be, I'm going to start with my 7 pi over 6, and I'm going to add multiples of 2 pi. Again, k, didn't need that comma, k is an integer. One last definition for you, a quadrant angle. Those are the angles that are on an axis. So I don't say they're in a specific quadrant. So for example, I'm going to come in and put this one a little bit thicker. If I have my angle here, so we know that we would measure that angle as pi over 2. So here my theta is pi over 2, and this is a quadrant angle because it's on the line between the first and the second quadrants. So here's a practice set for you with drawing some angles and determining positive and negative coterminal. So you do those and come in and check your answers in the notes completed document.